I was like, I have a one.
All right, so take a look at these.
I have one now.
So A, my mean is NP. So 100 times 0.75, 75. The standard deviation is NPQ. So it's 75 times 0.25. So it's 18.75. And the sigma would be the square root of NPQ. So the square root of, not that very well. NPQ, square root of 18.75, which is what? 4.33. 4.33. Sure. B, my mean is going to be 100 times 0.3, 90. Sigma, my variance is going to be NPQ, so 90 times 0.7, 63. And then my standard deviation is going to be the square root of 63, which is 7.94. Is that right?
Yeah.
Okay, great. Good. And then we'll take a look at the next one. So here, this is my N. And then, of course, my P is 0.5, right? Heads. So my mean is 10 times 0.5, 5. My standard deviation is 5 times 0.5, 2.5. And my variance is 2.5. And my standard deviation is the square root of 2.5. 1.58? Okay, good. And then the last one is, do people need to take a look at that again? Sorry.
Oh, no, that's fine.
All right, so here, where's my N and where's my P and where's my N? Okay, so the N is how many people I have random sample of. That's my N, yeah, so good.
Oh, 1,000.
Okay, perfect. Right, survey found, that 21%, that's my little p. Good deal. So I've got my mean is 1,000 times 0.21, 210. My variance is NP times Q, 0.79. What was that one? 165.9? Great, and then my standard deviation is the square root of 165.9, which is, I have no idea. 4.88? 4.88?
Yes.
Yeah.
We'll call it 12.9, that seems good. All right. Great. Questions on this part? We're good moving on? Okay. Perfect. Okay, so go ahead and put that away and get out your chapter 6 notes. We're going to work on that. One quick question about the about our. Did you have a question about stuff? No. Okay. One quick question about before we get started. What's the symbols again for our population mean, population standard deviation, sample mean, sample standard deviation? Somebody give me one of them. U is my population mean. What's the population standard deviation? The little O with the tail? Yep. Sigma. Sigma, my O with my tail. Good. And then sample. What's coming from my sample? S is my standard deviation. And what's the other one? X what?
X bar.
X bar. Good. X bar. Great. So you do need to know these. Make sure that you are paying attention to them. They're going to come up over and over and over again. All right. Quiz problem number 5. The Z-score represents the number of standard deviations short to SC. Okay. A value is above or below the mean. There are 5 parts to this that you need to have. The number of, right, or how many standard deviations, obviously that's important. a value is or something is away from or above or below or from, and then the mean. So yeah, all 5 of those pieces you need to have, otherwise it doesn't make sense. Right? The number of standard deviations value is above or below. Above or below what?
The mean.
The mean. All right, you have to have all those pieces. If you leave out one of those, the number of standard deviations of value is the mean. What? Is away from the mean. Right? Something along those lines. Right? The number of standard deviations above or below the mean. What is above or below the mean? Right? You have to give me all those pieces. I need to have all 5 of these pieces in there. Okay. So the idea is it does represent how far a value is away from the mean. So look at this first one. He's 1, 2, 3 standard deviations below the mean, -3. This guy here, he's 1.5 standard deviations below the mean, -1.5 is his z-score. This one over there, he's 1, 2, 2.35 standard deviations above the mean. So his z-score is 2.35. Right, so it's if you kind of jump standard deviations, how many jumps would you take? How many steps would you take? How do you find it? You take your value, you subtract the mean, divide by a standard deviation. That gives you the z-score. If it's above the mean, it should be positive. If it's below the mean, it should be negative. Right? Remember, these are all negative z-scores over here. Left side, these are all below the mean, negative z-scores. Above the mean, positive z-scores. That's going to be critical as we come up to the next thing we're talking about. Skip that one. All right, so Lauren, talk to me.
Okay. The shape and position of the normal distribution curve depends on 2 parameters, the mean and the standard deviation. Each normally distributed variable has its own normal distribution curve, which depends on the values of the variable's mean and standard deviation.
Perfect, thank you. So with the normal distribution, it depends upon, the shape of it depends upon 2 things. The mean and the standard deviation. Just those 2 things. Binomial depends upon 2 things. N and P. So with binomial, it's N and P, which is what you just found a second ago when you're finding all those means and standard deviations of it, right? But normal is the mean and the standard deviation. So what do they tell you? The mean tells you where it's centered at, right? Where the top of the hill is. The standard deviation tells you whether it's really pushed together or really spread apart, right? Whether it's a wide hill or a really peaked hill. So the top one, you'll see they have the same mean. They're centered at the same spot, but one is flatter and one's more peaked. They have a different standard deviation. The bottom one, you'll see they have the same shape, the same amount of flatness or round here, whatever tallness, but their means are the same. They're centered, are different. They're centered in a different place, so they have a different mean. There's some properties. First one is the area under the curve, the total area under the curve equals 1 or 100%, or represents the entire population. So if you add up all the area of the curve, we set it equal to 100%, because it represents the whole population. As you can see, a higher percentage is in the middle, where the mean is, and as you kind of go further and further away from the mean, it drops off as you get further away from the mean. There's fewer and fewer people who are out there in the outskirts. Other properties, the mean, median, and mode are all smack dab in the center. And it's symmetric. The left side is a mirror image roughly of the right side. They're symmetric, one side to the other. We went through this last class, right? We talked about this already. So it kind of leads us up to this. So this is the flip to the page that we went over last class. We did that one sheet that I said was like the beginning of the chapter 6 notes. And we did the first half. We didn't do the bottom half. So that's this part here. Alberto, go read to me.
For example, say the heights of all the lands in California are normally distributed with a mean of 70 inches and a standard deviation of 5 inches is normal curve would be similar to one below.
Perfect. Right, so it looked like this. Here's my middle, 70 inches, and then 1 standard deviation, 2 standard deviations, 3 standard deviations, right, as we kind of go out. Great. So questions we have for you. The first question is, comes around this. Very, very, very often, we want to know the cumulative relative frequency. In other words, what percent of the population is below this amount or above this amount? Right? What percent of the population has a height less than 60 inches or greater than 75 inches, something like that? That's stuff that we often want to know. So for example, let me ask you this. What percent of the population is less than 70 inches tall? I'm going to look up. What percent of the population is less than 70 inches tall? 50%. Does everyone see that? It's smack dab in the middle, 50%. Good, write it down on your sheet. How about less than 65%? So that's this part right here. So the first one was 50%. I'll write it over here. 50%. So, okay, so some folks have the answer to that. Let's take a look at where everybody's at. So here, we know that this part here is what? 68%, thank you. Great, so that means that if 68's on the inside, 68% is on the inside, I'm going to look up, 68% is on the inside, what percent is on the outside? Alondra, what percent's on the outside? 68% on the inside, what percent's on the outside? The whole thing has to add up to what? 1, right? 1 or 100%. So 68% on the inside, what percent's on the outside? 32. Everybody with me on that part? Okay, so if 32% on the outside, half of it is over here, half of it is over there. Good? When I'm not seeing faces, I get worried because I'm not sure what they're looking at. All right, so half of it's over here, half of it's over there. So what's half of 32? So there's 32% that is in these pieces here. So how do we find this part over here? Divide by 2. Yep. 16%. That's the percent, that's the part that's less than 65 inches tall. All right, so I will give you folks a hint. If you do not want me to call on you, then definitely don't be looking at me, because people who are not looking at me, I'm more likely to call on them for answers, because I'm not sure what they're doing. Does that make sense for folks? So if you're not looking at me, there's a good chance I will just call on you randomly. So I want to make sure you're with us and not somewhere else. Okay. What percent of men in California are less than 60 inches tall? So less than 60 inches is this part over here. Right? So again, we should look at what our inside part is. That's within 2 standard deviations. Do we know what that part is? What's that part there?
95.
95%? Okay, so 95% is on the inside. What percent's on the outside? 5%. 95% is on the inside. The rest of it, 95% is on the outside. Make sense for folks?
Yes.
Great. So these two parts here make up 5%. Half goes here, half goes there. What's half of 5%?
2.5.
2.5. Exactly. 2.5%. So less than 60 inches is 2.5%. What about greater than 60 inches? So that would be, hang on, I'll get it for you. That would be this part right here going off forever. What's that? Let me draw another picture. Maybe I'll make it clear. This part is 2.5. What's this part? What's this part here? Anybody else know? Just one person? Raise your hand if you know.
Yeah, I know. Yeah.
Only 4 people? 5 people? 6 people? So this part over here on the left is 2.5%. Sorry, percent. I should put percent. My bad. 2.5%. What's the rest of it on the other side? 97.5%. Right? Because it all has to add up to 100%. So that's this part here. All right, how about greater than 80%? All right, sorry, greater than 80 inches, my bad. Greater than 80 inches. So this part here shaded in orange, what's that?
2.5.
2.5. Why? It's symmetric, exactly. Good. All right. Now here's the problem. That's all well and good if someone happens to fall exactly on a whole, on one of the standard deviations. Then I can figure out what's below their height or above their height. But what if they don't? Like, what if they're 64 inches? I want to know what's probably someone is 64 inches or less. It doesn't cover that. So what we could do is we could figure that all out, make a whole table and say for each tenth of an inch or hundredth of an inch, and have this giant table that would give you all the percentages below and above each number. The problem is it would only apply to this one data set. So, and that's not super useful because it's a lot of work, right? So instead, what we've done is we've made one that applies to the standard deviations, to the z-scores. And so then, all you have to do is take your numbers, convert it to a z-score, and you can just use the z-score one that applies to every normal distribution. Right? Pretty ingenious, right? So the best thing too is they've taken all those percentages for each of those z-scores and they've stored it into your TI 8384 calculator. So they're all in there. So now we're going to use that. How do we do it? So this is in your notes on the next page. Very top of the next page. You're going to write in how to use the TI calculator, find the area under the curve between two z-scores. You're going to use normal CDF, right? Write that in there, normal CDF of the left z-score, comma, the right z-score. That gives you the area between the two z-scores. How do you get there? How do you get to normal CDF? You do the second key. Remember we've done the second key already to get L1 and L2. Remember that? So we do the second key, and instead we do bars, the bars key, which I'll show you where it is in a second. And then we go down to normal CDF. So in other words, if I want to find the z-scores between -1 and 1, I will do it like this. On. So I'm going to do the second key right here. Second. And I hit the bars key, which is kind of kitty corner from the stack key. It's right here. Also near the arrows. Second bars. And then just arrow down one to normal CDF. Not PDF, you want CDF. Normal CDF. Hit enter. I want -1, comma +1. Here's the deal. You cannot use the subtraction sign to get a -1. I can't use that. Instead you have to use, everyone look up. Everyone look up, look up, look up. You have to use this little negative in parentheses sign to get a negative symbol. That's how you get a negative number. So I hit negative this to get -1. So I'll go ahead and do that. -1. And I need to put a comma. Comma's above the 7. Comma 1. Bam. There we go. If you have a fancy TI 84 calculator, it will ask you for the lower limit and the upper limit. Right? Lower level, upper level. Anybody have one of those?
No.
Let me see yours. Right. So that's okay. So it'll have the lower and the upper in there. So you're going to put -1 in the lower, +1 in the upper, and leave the mean at 0, standard deviation at 1. I'll say that again. Leave your mean at 0, leave your standard deviation at 1. But put your lower number, the left one and the lower one, and put the upper one, the positive one in the upper. Good? Everybody all right with this part? Okay. Pause this for a minute.